Hey guys, Jake here coming at you with another math lesson today. Today we're going to continue our discussion about the foundations of differentiation. We're going to be diving now into how to find the derivative of a composite function, or in other words, we're going to be talking about the chain rule. Before we jump into the topic and the problem though, be sure to go check out my new book, The Elite Guide to AP Calculus AB. You can either scan the QR code up in the corner of your screen or go check the link down in the description or pinned comment below. Well, let's go ahead and dive into it. So before we actually jump into this example, I do want to take a brief second to just talk about the chain rule itself. So chain rule essentially says that if we want to find the derivative with respect to x, let's say, of some composite function, which we will call f of g of x, this derivative is just going to be, there's really just a formula, which you can kind of just memorize, but basically this formula is the derivative of the outside, leave the inside function alone, so f prime of g of x, and then multiply that by the derivative of the inside function, so g prime of x. So the way I kind of just read that as I wrote it is how I like to remember this formula. I don't think it's particularly helpful to just see this and try to memorize, f prime of g times g prime. I don't really find that helpful personally. So what I like to do is remember the way I just read it, right? The derivative of the outside. So you're taking the derivative of your outside function, your f, taking that derivative, so that's f prime. Leave your inside function the same, so leave g of x as g of x, and then multiply that by the derivative of the inside function. So you're kind of taking a composite function where you have a composite function essentially is just one function plugged into another function, and you're just going to basically take your derivative from the outside in. So you're going to start at the outermost function and work your way in from there. So in this formula and in this example we're going to be going through, we really just have an inside function and an outside function. We can essentially break this composite function down into just two kind of layers of functions. However, the same concept applies if you have 3 or 4 or 5 or more functions, a composite function that is made up of multiple, many layers of functions. You can kind of just start from the outermost function and work your way in from there. So for example, let's say we wanted to find the derivative of f of g of h of x. So we have 3 functions kind of being plugged into each other. We would, again, just start from our outermost function and work our way in. So we would get f prime, leave our inside functions the same, and then multiply that by the derivative of the next layer in. So then g prime, leave our inside function h of x the same, and then multiply by the derivative of that innermost function. So you're essentially just doing kind of one derivative at a time, where you're just going one layer further in and leaving everything inside of that the same. So that's the way I like to remember it. So let's go ahead and think about how we can actually apply. We don't really need to worry about this formula here for this problem because we just have cosine x cubed, which the first step you want to think about is what is your inner function and what is your outer function. That's generally going to be where you want to start with these problems. So looking at this function here, cosine of x all raised up to the third power, usually it's easier to think about what is your inner function first. So what is your innermost function is essentially where you want to start. In this case, looking at this cosine of x all cubed, these parentheses are usually going to be kind of a good hint of what your innermost function is, because if you have some elementary function inside parentheses like this, that would be usually a good indicator that that's going to be your inner function. So we will call cosine of x our inner function, which, if we want to think about it in terms of the formula here, that would make cosine of x our g of x. Okay? And then the reason I like to start with the inner function is once you find that inner function, you can go back to your original function that you're trying to find the derivative of, and imagine taking out that entire inner function and replacing it with just x. So let's imagine if we got rid of cosine x here, our entire inner function and just changed it to an x, whatever's left will be your outer function. So now our outer function is x cubed. So we're going to get x cubed as our outer function, which, again, if we want to kind of compare this to our formula, our outer function is f of x. So once you've kind of broken down what is your inner function and what is your outer function, you can then just apply the formula. Similarly, we could kind of apply the same, wording, verbal logic, I guess you could put it, of how I said it before. So you take the derivative of the outside function, leave the inside function the same. So if we want to take the derivative of x cubed, let me go ahead and actually change this back to cosine of x. So we want to take the derivative of the outside function, which is the x cubed part. So if you're taking the derivative of x cubed, that would just be power rule. I actually just made a video about power rule. If you want to check that out, I'll put the info card up at the top. You can check that out. But the derivative of x cubed, we would simply take our power, bring it down in front as our coefficient, and then subtract 1 from the power. So our derivative of our outer function is going to be bringing the 3 down in front and subtracting 1 from our power to make it a 2. So 3 times something all squared is going to be how we apply the derivative of the outer function part. So you take the derivative of the outer function, leave the inside function the same, so leave cosine x as cosine x, and then multiply that by the derivative of the inside function. The derivative of cosine x is what we would multiply that by. So the derivative of cosine x is negative sine x. So now from here we can pretty much just simplify. This is going to be our derivative. So if this was our original function f, this would be f prime. So then there's really not much simplifying to do here, but essentially we could kind of just rearrange coefficients, put everything a little bit neater, essentially just giving us negative 3 times sine of x times cosine squared of x. Cosine of x in parentheses all squared is the same as cosine squared of x. This notation here, putting the 2 here instead of here, means the same thing. Do be careful though, that's not the same as cosine x squared. If you see it written like that, that implies that just the x is being squared, not the cosine. So if you do want to say cosine of x all squared, you would write it this way. Anyway, a little bit of a off topic there, but that's okay. So that's pretty much it. That's how you apply the chain rule. So I hope you find this video helpful. If you did, be sure to give this video a like, subscribe to the channel too. We're going to be doing lots more problems and topic discussion from my book, The Elite Guide to AP Calculus AB, in the coming weeks and months. So be sure to go get yourself a copy of that book in the meantime, and hope you get all prepped for the AP exam coming up in May. Thanks, and see you next time.